Bismillahirrahmanirrahim. Assalamu alaikum students. Here I am your maths teacher from IYS schools. Now there are some objectives we have to discuss in today's lecture. First one is types of sets. Second one is subset and superset. Third one is proper and improper sets. Fourth one is equality of sets. And the fifth one is one-to-one correspondence and equivalent sets. Okay, the first objective is types of sets. Okay, there are three types of sets. The first one is finite sets. Second one is infinite sets. And the third one is empty set or null sets. I repeat it, students. There are types of sets: finite sets, infinite sets, and empty sets or null sets. How we define them? The first one is finite sets. A set having finite number of elements is called a finite set. All the members of finite set can be counted. I repeat it. A set having finite numbers of elements is called a finite set. All the members of a finite set can be counted. For example, A is equals to braces A, B, C, and D. These are the countable sets. Second set is set B. It starts from 1. As you see, 1, 2, 3, 4, 5, 6, and up to 100. These numbers are also countable, so such kind of sets are called finite sets. These are the examples. The next one is infinite sets. A set having infinite numbers of elements is called an infinite sets. Okay, we cannot find the number of elements in an infinite set. It means that we don't know about the last number of this counting. Here are the examples. C is equals to 1, 2, 3, 4, 5, and there is no last number right here because we don't know about the ending of this counting. Second one is B is equals to, okay, there are some dots and the counting start from -2, -3, 0, 1, 2, and up to so on. Okay, as in our previous lecture we discussed, such kind of set is called integers. Set of all integers, and we don't know about the last number of these integers. So such kind of set is called a infinite sets. These are the examples of infinite sets. Now the next one is empty sets. A set which contains no element is called an empty set or null set. It is denoted by phi or simple braces. There is no element inside these braces. For example, a set of birds having 4 legs. In such kind of sets, we cannot find even a single member of the set. It is an empty set. Okay. Here is the important thing which I will discuss with you. A set containing 0, as the only element is not an empty set. It is the set and it contains one element, the number is 0. So you don't write 0 inside these braces. If there is an empty or null set, We write only the braces, not we write there 0 or any number else. Okay, the next one is, these are the symbols and their meanings. Okay, the first symbol, this one is, we look, as we see in our previous lecture, this symbol is called belongs to, or its mean element of. The next one is, this symbol is also just like belongs to, but there is a sign which cut this symbol, and this is called not the element of or not belongs to. The third one is this symbol. This symbol is called proper subset. Okay. We discuss proper subset and subset later, so please hold this. The next symbol is used for the subset of. This symbol is used for is not a subset of. Okay, the last one is contains proper. We discuss all these symbols later in our this lecture, so please students listen carefully. This is your home task. I discuss home task at this moment because these home tasks is related to our previous discussion. We previously discussing about the belongs to or not belongs to, finite or infinite sets or empty set. So I will give you the home task at this moment. This home task is on page number 6, size number 1.1, question number 1 and 2. As you see, students, question number 1, if a set A, 2 and 4, then state what each of the following statements are true or false. You done all these parts in your fair copy of your subject. You write only true and false. The next one is question number 2. If there is a set A which having the element 1, 3 and 5, and the set B which having the element 1 and 2, then fill in the blanks with these symbols. These symbols, as we know that this symbol is used for not belongs to or not the member of. The next one, this symbol is used for belongs to. Okay, these blanks filled with these symbols only. If we know that one either belongs to A set or not, so we write here only the symbols. As you see in this question, in a set A, there is also element 1 here. So here we write belongs to symbol. This means 1 belongs to A. Okay, you fill all the blanks with these symbols. This one is the second home task for you students. Okay, this is the question number 5 from exercise 1.1, page number 7. Question number 5 is sort out finite, infinite and empty set. Here again, here I again repeat, students, please listen me carefully. I will discuss this home task at this moment because we already discussed finite, infinite, empty set. So don't have any confusion. Solve these in your fair copies only. In question number 5, only you sort out which one is the finite set, or which one is the infinite set, or which one is the empty set. The next objective of our lesson is subset and superset. Now, what are the subset and supersets? Subsets are, let A and B be two sets, which means that A and B are two sets if every element of A is an element of B. Then A is called a subset of B. Subset is denoted by this symbol. As I already told you that students, these symbols I laterally discuss, so I discuss here. Please note it down. This symbol is used for subset. I repeat it again, students. Let A and B two sets if every element of A is an element of B. Then A is called a subset of B. Subset is denoted by this symbol, and we write this A is a subset of B if A belongs to A. This A is an element and this A is a set. So the element belongs to A set implies that A is also belongs to B set. So these sets are the subset. The next one we have superset. If every element of A belongs to B, it means that if every element of set A belongs to set B, then B will be the superset of A. It means that in the above example, if A is a subset of B, then B is a superset of A. The next one is proper subsets. Now, what are the proper subsets? If two sets A and B, if every element of A is also an element of B, then B contains at least one element which is not an element of A. Then A is called a proper subset of B. As you see in this example, this is only the example, proper subset. If A contains A, B, C and D, and we have another set which is B having the element A, B and C, then B is a proper subset of A, and it is denoted by this symbol. B is a proper subset of B. Proper subset or simple subset denoted by this symbol. The next one is improper subsets. If every element of set B is also an element of set A, then every element of set A is also an element of set B, then B is an improper subset of A, and also A is an improper subset of B. As you see, students, here, if we have a set A is equals to 1, 2, 3 and 4, and B having the elements are 2, 4, 3 and 1. So as you see here, all the elements are same, but their arrangement are different. Then B is an improper subset of A, and also A is an improper subset of B. It is denoted by, if we say that B is an improper subset of A, so we write this time. And if we say A is an improper subset of B, So we write okay students, here if we consider the definition of a subset carefully, then we find every element of A is also an element of B. As you see, every element of A is also an element of A, and so A is a subset of itself. Then every set is a subset of itself. And A is called an improper subset of itself. Now the next one is equality of sets. Okay. Equality of sets means if we have two sets, A and B are said to be equal if there are two conditions here. Every element of B is also an element of A. Second condition is every element of A is also element of B. Here is the example. If A is equals to 2, 4, 6 and B is equals to 4, 6, 8, then A is equals to B. Okay, here are some important points. Listen carefully. The first point is if two equal sets are just two names of the same sets. I again repeat it, students, please listen me carefully. Two equal sets are just two names of the same set. Second point is, in describing a set, the order of the arrangement of its member is not at all important. It means that the arrangement of these elements is not at all important, but the elements are same in both sets. Over the third point, we have two equal sets are also improper subset of each other. I repeat it. Two equal sets are also improper subset of each other. This is called the equality of sets. This means that all the elements in both sets are equal. Arrangement doesn't matter. Arrangement are same or not same, but all the elements in both sets are equal. Now the next one is one-to-one correspondence. What is one-to-one correspondence? Here is an example. If we have a set A is equals to A, B, C, and a set B is equals to 1, 2, 3, then how we explain they are one-to-one correspondence? Okay. There is a complete correspondence between the members of set A and B. As you see, to each member of set A, their correspondence one and only one member of set B. As you see here, students, I show one-to-one correspondence by these arrows. It means that in set A, the element A is corresponding to the element 1 of the set B. Then next one, B is one-to-one correspondence to the next element of set B, which is 2. The third element of set A, which is C, is correspondence to the third element of set B, which is 3. In such case, the correspondence between the members of set A and B may be set up also the following ways. The correspondence can also be set up in some more ways, but the correspondence will be completed in each case. Thus, to each element of set B, there corresponding one and only one element of set A. As you can see, students, here, no element is left in both sets. All the elements correspond to the all elements of the other set. Then two sets A and B are said to be in one-to-one correspondence. Okay, there is also an important point here. When A and B are equivalent set as one-to-one corresponding can be established between them. As you can see that the member of set A, there are 3 members in set A, 1, 2 and 3. We only count them. We don't look they are ABC, we don't look they are XYZ or 1, 2, 3 and anything else. So we only count these elements. Set A having 3 elements and set B also having 3 elements. So A and B are equivalent sets as one-to-one corresponding can be established between them. Okay. There is another example. Another example, as you see, if we have a set X having the elements 3, 6, 9 and 12, and we have another set Y is equals to X, Y, Z only. So as you can see, the number of elements or the number of members in set X, there are 4 elements of 4 members. We only count them 1, 2, 3 and 4. There are 4 elements in set X and there are only 3 members in set Y. So if we establish their correspondence, so they are not one-to-one correspondence, because if 3 is corresponding to X, these arrows show the correspondence between these elements. And if 6 is corresponding to Y, then 9 corresponding to Z, then 12 is corresponding to Y. Which element? There is no any other element in set Y. So such kind of sets, hence the set X and Y are not in one-to-one correspondence, and therefore they are not equivalent. As you can see, the number of elements in both sets, just like the set X having 4 elements, we only count them having 4 elements, 1, 2, 3 and that's it, 4 elements. And the set Y having elements X, Y and Z means there are 3 elements. So they are not equivalent sets and we must not establish one-to-one correspondence. I hope you will understand this, or otherwise we ask in the last of my lecture in your chat box. You may ask question in your chat box and I will discuss in the last of my lecture. Okay, this one is your home task. Okay, students, I repeat it again. There are 3 home tasks for you. The first 2 home tasks is from exercise 1.1, page number 6 and 7. And this one is the second home task. which is on the page number 13 from exercise 1.2. Okay, this is your home task. In those home tasks, there are some sets given to you. Question number 1. Only the question number 1 you have done in your fair copies. Question number 1 is if there are some sets A set, B, C, D, E, F, G, and H. These sets are given to you. Then state whether each of the following statement is true or false. You only understand these sets and write here the true or false. So if we discuss some parts of these true and false here, the first part is B is a subset of A. It is true or false? Now come on, look here. B having the elements 1 and 3 and A having the elements 1, 2, 3 and 4. So you can see here 1 and 3 are present in set. So here students, as you can see 1 and 3 are also the elements or members of set A. So this statement which is read as B is a subset of A is true. Now the next one is this one is read as A is a superset of B. These two symbols are different from each other. This symbol is for superset. So here A is a superset of B. As you can see, A having all the elements and B its subset. So this statement is also true. Now students, you can do yourself other the same parts. Okay, here we discuss this part number 9. A is equals to B. How we define this A equals to B? Where's the A set? This one is the A set. A set having the 4 elements and B set having 2 elements. From the definition of equality, all the number of elements are equal in both sets and the elements are also same. So if A having the elements 1, 2, 3 and 4, but as you can see inside B there are only 2 elements which is 1 and 3, so they are not equal. So this statement is false. Now we move towards these C and D are one-to-one correspondence. Where is the C and D? This one is the C and D. Yes, they are one-to-one correspondence because the first element is correspond to the first element of set D. First element of set C is 3 and the first element of set D is 8. So they are one-to-one correspondent. Second element of set C is 1 and the second element of set D is B. So they are corresponding to each other. So this statement is true. This statement is true. C and D are equivalent sets.